So we are starting chapter 6. This is in your textbook called The Concept Bite, but it's just a review of all of the exponent rules that you learned back in Algebra 1. Okay? And we're going to go through briefly each rule, and then we'll start putting them together to simplify some expressions. Okay? The 7 rules that we have are listed in this chart here. Our first rule says that anything to the 0 power is 1, with the exception of 0. All right? We don't think of 0 to the 0 power being 1. But anything else to the 0 power is equal to a 1. That allows you to simplify things nicely when you see things raised to a 0 power. Our next rule says that if we take something to a negative exponent, we actually have to take its reciprocal. So a to the negative n power is the same as 1 divided by a to the nth power. So by flipping it over, we are allowed to change that power to a positive sign. And one of our rules when we simplify expressions is we never leave negative exponents. All right? So if you have any negative exponents in your answer, you need to flip those. Our next rule says if we have a base to a power and that same base to another power, the shortcut is to add the exponents. Okay? Now, students often get mixed up. When am I supposed to add, subtract, multiply those exponents? If you find yourself getting mixed up, think of making a pretty small example and seeing what should happen. For example, for this last rule here, a to the m times a to the n. If I think of x squared times x cubed, that would be the same kind of question. What does it mean to take x and square it? There's 2 of them, right? You're multiplying an x times itself. What does it mean to take x and cube it? There's 3 of them. So if I have all of those x's getting multiplied together, I can simplify it by saying it's x to the 5th. All right, so does it make sense that we're just adding the powers? Okay. Next rule says if we are dividing and we have the same base, we can subtract the powers. So again, think of an easy example. X to the 4th divided by x to the 3rd. Well, picture x to the 4th being 4 x's multiplied together and x cubed being 3 of them. If we start crossing off common ones, how many do we have left? We have x to the 1st power. Okay, so again, the shortcut is just to subtract the exponents. This rule says if we have a product, a times b, raised to a power, we have to think of distributing that power to both factors. So the a gets raised to the nth power, and so does the b. Here we are dividing. Same thing though. We have a quotient raised to a power. We're going to raise both the numerator and denominator to that power. And the last rule, if we have a base to a power to another power, we multiply them. Students often get these 2 rules mixed up. When do I add? When do I multiply? Again, think of a basic example. So if I said x cubed squared, squaring something means you're timesing it by itself. Okay? X cubed means I have 3 x's multiplied. So I have a total of 6 x's getting multiplied together. Does that make sense? Okay. So what we are going to do is use all of these rules to simplify some expressions. There are often multiple routes you can take to get to the same answer. All right, I'm going to try today to point out some of those different options to you. You may have learned it one way in Algebra 1 and that makes sense to you. That's fine. Okay, as long as we can get to the same answer, we're fine. A couple things that are common mistakes students make is they try to apply these exponent rules to things that aren't exponents. For example, coefficients. Those are those numbers in front of our variable. Okay? If a coefficient is negative, you don't have to flip it. We are only using negative exponents and flipping them over using that reciprocal rule. Okay? The other thing is when you have a coefficient raised to a power, that's not the same as a power to a power. Okay? That rule doesn't apply. So coefficients, you do what it says you should do. There are no shortcuts to it. Okay? So in our first example, we have a 5 and a negative 3 as our coefficients. What is it telling me in that question to do with those? It's saying to multiply them. So we're going to multiply them. 5 times negative 3 is negative 15. Now again, that is a coefficient. It's okay for the coefficient to be negative. We don't have to try to flip it. All right? You can't. Negative 15 is not the same as 1/15. Okay? Then we look at our variable pieces. Do we have common bases? Is it the same base? Okay, they're both A's. What do we do when we have a base to a power times the same base to a power? We add them. Okay, so what do we get if we add a 3 with a negative 4? Negative 1. Can we leave our answer like that? No, because we said we can never leave negative exponents in our answer. So what are we going to have to do with that A? We have to take its reciprocal. Okay? And when we take its reciprocal, the power becomes positive now. So we are going to write this final answer as negative 15 over an A. If you want to put the little exponent in there of a positive 1, you can. It's not needed. Your book typically wouldn't put it in there. All right, but it wouldn't be marked wrong if you left it there. All right, our second example. Notice we have several things in parentheses, and all of it is being squared. Couple different routes. Some people will distribute that square right away. What I mean by that is they would take each of these pieces and raise them to that second power. Okay, that is one option. If we did that, what do we get when we take negative 4 and square it? We get a positive 16. For our x's, what do we get when we take a power to a power? What do we do with them? Power to a power. Multiply them. So negative 3 times 2 would be negative 6. Power to a power for y. We get y to the 10th. Okay, now, what has a negative exponent? The x, and just the x, right? It's the only thing being raised to the negative power, so that's the only thing that has to get moved. Okay, so our final answer here, the 16 and the y to the 10th would stay in the numerator. The x to the 6th now ends up in the denominator. Okay, and what I said earlier about several different routes you can take. Some people would look at this second example here, and they'd say, I'm going to take that x piece because it has a negative power, and I'm going to flip it right away. Okay? And they would look at this as negative 4y to the 5th over an x cubed, and then they would deal with the square. And that's fine. We can get to the same answer doing that. Either one is perfectly valid. Okay? All right, example 3. Notice that we have the same variables in the numerator and denominator, so we want to simplify those. Is there anything I can do to simplify the coefficients? I have a 4 in the numerator and I have a 1 in the denominator. 4 divided by 1 is 4, right? There's nothing I can do to reduce that. So I'm going to go ahead and leave that as a 4. Then I'm going to take my variables in pieces. Focus on the A's first. What's the rule that we have when we have variables in the numerator and denominator? We subtract them. So what do we get if we take this 1 here and subtract the 5? Okay. Looking at the B's, we have 6 in the numerator and only 1 in the denominator. Subtracting would leave us B to the 5th. And if we look at the C's, we have 3 in the numerator and 3 in the denominator. What's going to happen? They cancel out. If we were following that rule of subtracting, we'd say it's C to the 0, right? But what is anything to the 0 power? 1. Does timesing by 1 do anything? No. So this really has no effect on my final answer. Okay? Can I leave that as my answer? What do I have to do? The reciprocal of which piece? Of the A. So, final answer. The 4 and the B to the 5th would remain in the numerator, and the A to the 4th would move to the denominator. Okay? Now, some students want to be able to go from here to here without that middle step where we get negatives. And we can do that. If you picture where you have extra variables. So looking at those A's, it says I have 1 in the numerator and I have 5 in the denominator. And if I start crossing off the common ones, what do I have left? I have 4 of them where? In the denominator. And that's what I'm showing here, right? There's 4 of them left in the denominator. So rather than always saying I have to subtract, you might want to take the technique of where do you have the extras? Because if you have more in the denominator and you subtract, you're going to end up with a negative number, which is then going to have to flip. Okay? All right, question 4. Notice that you have a group of items being raised to a negative 3 power, and then at the end, you have similar bases that we want to multiply in. Okay? We have to deal with this first. We have to deal with that power that's being applied to those pieces before we try to combine it with these. Okay? So, distributing my negative 3. I'd have 2 being raised to a negative 3 power. What about the R? Power to a power, we do what? Multiply. So the 3 times the negative 3 would be negative 9. And then the T would be to the 15th. Okay. Now can we put our R's together and our T's together? Okay, so we have 2 to the negative 3. We have R to the negative 7. What about T? Where's the 16 coming from? Yes. The last T there is a T to the first. If it helps you to put the little 1 in there so you don't forget about it, go ahead and do that. Now I can't leave that as my final answer because I have 2 pieces that are raised to negative exponents. What happens when I take 2 to a negative 3 power? What am I going to have to do? I have to do 2 things. I have to cube the 2, and because of the negative power, I have to do its reciprocal. What is 2 cubed? It's an 8. If I do the reciprocal of 8, I get 1/8. All right, so I'm going to have an 8 in the denominator. The R to the negative 7, what am I going to do? Do I have to move that piece? Okay, so the R to the 7th is going to go to the denominator. How about the T? Do I have to move that? All right, so the T to the 16th would stay on top. That would be my final answer. Okay? All right, the 5th one here, again, looking at the different options. One option is to take that 2 that you see outside the parentheses and distribute it to all the pieces inside. Another option is to simplify all the stuff inside first and then distribute the 2. Which do you want to do? Simplify first? All right. Can we simplify a 3 and a 5? The coefficient part. Okay, so we'll leave that. How about the x's? How many do I have in the numerator? 2. How many in the denominator? 1. If I take off 1 from each, I have 1 left in the numerator. All right, look at the y's very carefully. I want you to think about how many you think are left. What did you come up with? Anybody? I heard 3 from 1. I heard -3. What do you think? If I picture these y's that have a negative power needing to flip, they're going to move where? They're going to move to the top, which means I have a total now of 2 here and 1 more. I do have a total of 3. If you followed the rule of subtracting, you're still going to get 3 because we subtract the powers. 1 minus a -2 is really 1 plus 2. Does that make sense? Okay. And then for the z's, we had 5 in the numerator and 2 in the denominator. So we have 3 left in the numerator. All right, take a minute and go ahead and square that now. All right, looking at squaring this. 3 squared should give us a 9, and 5 squared would be 25 for the coefficient part. Looking at our x's, we have x to the first raised to the second. Power to a power, we multiply those exponents. So we end up with x squared. For the y's, we get y to the 6th and then z to the 6th as well. Okay. On your table, you have a white sheet that has a few extra questions on it. The first one looks long and complicated, but does anything jump out at you? Yes. We have some 0 exponents. Since this whole thing is being raised to the 0 power, it becomes a 1. And multiplying by 1 doesn't do anything. So the effect is that that's just gone. Any other zeros for exponents? In the last parenthesis, this one, y to the 0 would be 1. Again, multiplying by 1 isn't going to change anything. So we can eliminate those little pieces. All right. Go ahead and work through this and then check in with the person you are sitting with. All right, I put down the first step. I distributed the 2 to all pieces, and then I distributed the 3 as well. Okay, now simplifying. 2 squared is a 4. -3 cubed is -27. We are multiplying those together. Remember, those are coefficients. There is no shortcut. You cannot apply those power rules to coefficients. So what is 4 times -27? Okay. All right, now, looking at the x's, we have a -4 and we have a -15. If we add those together, we're at -19. We can't leave negative exponents, though, so we're going to flip that. So our x to the 19th is going to land in the denominator. And then the y's, we just have a y to the 6th. It's not negative, so it's going to stay where it is. All right, looking at the second one. Do you see things inside the parentheses that you could simplify? Then I would do that first, all right? Rather than cubing everything and then trying to simplify it. So the 4 and the 12, what would that reduce to? 1/3. Okay, looking at our x's. If you have negative exponents, picture moving them. So this x to the -3, I'm going to move it down here. So how many x's now do I have? I have 5, and are they in the numerator or denominator? All right, so I'm going to have 5 of them down here. Looking at the y's, both of them have negative powers. So both have to flip, which means the y to the negative 5 is going to move up here, and then the y to the negative 2 is going to move down there. So the net result is what? 3 of them where? On the top, okay? All right, and then looking at the z's, we don't have any negatives, so I'm not going to move anything. If I have 6 in the numerator and 4 in the denominator, what do I have left over? 2 of them in the numerator. All right, now I can take that and cube it. All right, so what do we get if we take 1 and cube it? 1. Take 3 on the bottom and cube it. 27. All right, so we've dealt with our coefficients. Now, we have a y cubed to the 3rd power. Power to a power, we multiply. 3 times 3 is 9. So y to the 9th. Okay? Z's. We have 2 here, 3 here. We're multiplying those. We have z to the 6th. And then in the denominator, we have x to the 5th. That's getting cubed, so it becomes x to the 15th. Okay? All right. The third one here, I want you to try with your groups. Do not move on to the back side. Those 3 questions are a little different. I want to talk through them before you try them. All right, looking at some options. What do we have here that we could reduce? What would that reduce to? A 1 and 4 with one of them being negative. Does it matter which one we make be the negative? No. All right. Can we then reduce this 4 and this 8? Yes. The 4 is in the denominator, so we're really taking 8 divided by 4. And then multiplying the negative 1 and the 2, our coefficient is going to be negative 2. We good with that? All right. Now, looking at the variables, I've got some negatives in there for exponents, so I'm going to go ahead and move those. All right. I'm going to bring this x squared down here, and I'm going to bring the z to the negative 3 up to the top. Okay, so now everything's positive there. On the second parenthesis, the only thing I have to bring up is one of those x's. Okay, so now find all of the x's. We don't have any on the top. We do have 2 in the denominator. On this one, we have 5 here and 1 here. So total x's in the numerator would be 6. Total x's in the denominator is 2, which results in x to the 4th. Does that make sense? Okay. Looking at the y's. I have 6 of them here. I have 2 of them there. And I have 1 there. What's the net result going to be? 7 of them. Okay. And then looking at the z's, we have 3 here and 6 there. So we have z to the 9th. Okay. Before we start on those last 3 questions, what do you notice that's different about them? They don't have variables, first of all. What else? Okay, we don't have all the parentheses that we've had in the other ones. Most common mistake is students see powers like the 6 and the 2 here, and they say, I just got to add those together. But that rule only applies when the base matches. And we have different bases here. One's a 4, one's an 8. We cannot put those together the way they are. So what I want you to do is grab your purple power chart. Have you guys seen a power chart before? Okay, I'll go through real quick what it means. Look at the far left column here. Think of this as your base. Across the top is what that base is being raised to. So, for example, find a 5 over here on the far left, and now what is it to the third power? So read across till you find the third power. What do we see? 5 cubed is 125. Does that make sense? So what I want you to do, in example 4 here, we have a base of 4 and 8. Is there a row on your purple sheet that has a 4 and an 8 in it? Look for a row, not a column. Is there a row that has a 4 and an 8? Yes? Look back. What's the far number on the left-hand side? A 2. That means 4 and 8 are powers of 2. So we're going to rewrite that. Instead of a 4 here raised to the 6th power, I'm going to think of 4 as 2 to the 2nd. Right? It's 2 squared. And instead of an 8 raised to a 2nd power, I'm going to think of that 8 as 2 to the what? 3rd. Now do we have the same base? Yes. So now we can simplify. A power to a power we multiply, so this would be 2 to the 12th. Here, power to a power makes this 2 to the 6th. And then how do we combine those? We add them, so 2 to the 18th. Okay? So I want you to try the next two. Check in with the people in your tables. All right, what base did you use for this next one? 5s? So we didn't change the 5 to the 18th, but the 25 we had to rewrite as 5 to the 2nd. And then raised to the 10th makes it 5 to the 20th. So you should have ended up with 5 to the 38th power. Okay? And we're going to leave it like that because 5 to the 38th is a huge number. All right, we're just going to leave it in its exponent form. All right, last one. What base did you use? 2. So we had something to the 6th, we have something to the -2, and we have something to the 5th. And we're going to change these so that they're a base of 2. 8 is the same as 2 to the 3rd. 32 is the same as 2 to the 5th, and 16 is 2 to the 4th. All right, power to power, we multiply. And then if we have the same base to powers, we can do what? Add them up. So 18 plus -10 would be 8, plus another 20. We have 2 to the 28th. Okay, so homework tonight is going to be this green worksheet. It is a puzzle worksheet. The puzzle is there so that you can tell if you're doing them correctly, but that's not the main goal of the questions, right? It's simplifying them. So if you bring it back next week and you just have the puzzle filled in and no work, it's not worth points. Okay? Remember on Monday,